So again, hello and welcome to our second session on Safe Perforating Systems. If you joined us a couple weeks ago, we talked about some of the detonator systems and such, and we'll be keeping with that theme. My name is Steve Wierenga. I'm the Business Development for Canada for Spartek. I'm based out of Calgary today. Actually, since the COVID hit, I've been based out of Calgary every day, but we're glad you took the time to join us. Again, we'll be using the chat features, so if you have questions, by all means, please go ahead and use that feature, and we'll either answer as we go from the Spartek team, or we will pause during the presentation to take some questions, and again, at the end of the presentations to follow up. So as I mentioned, we did our first session a couple weeks ago where we talked about fire sets and switchable systems with the different groups of detonators as per the new RP67 that just came out in October last year. We're going to continue on this theme today. We'll be talking about two more of our items in our catalog, and that is the electronic ballistic triggers, the QCT, quick change trigger, as well as really isn't a ballistic device per se, but the fast sapphire gauges for capturing and recording perforating events. So we've tucked that into this session as well. So to start off, we'll chat about the quick change trigger, the QCT, which is the Spartek electronic firing head. Now this is a field replaceable control cartridge. It's designed for detonator and igniter packages for ballistic devices. There's a multitude of them. We'll talk about the different configurations. This is a battery powered programmable firing module with a memory capture capability, so it can be run without using E-line. The main applications of this tool would be the slickline being primary, tubing conveyed, be it jointed pipe or coil. It's able to run conventional perforating devices, tubing conveyed perforating devices, tubing punches. We can initiate igniters for setting packers and plugs. We can initiate some downhole sampling tools, dump bailers, and various other compatible downhole ballistic operations where you can utilize a detonator or an igniter. Now, as we discussed here earlier, the new API RP67 third edition just came out in October of last year. This is available through the API portal. And in here, there are a few items that are going to specifically give us direction on how the best practices recommends we use these electronic systems. Section 7 would be the slickline section, and specifically 7.6.23 is where we're going to find the parameters that we want to operate our triggers under. You'll also find references to these triggers in the tubing conveyed operations and the perforating operations, and then in the actual operations mode of the slickline. The section 7 is the perforating systems that you can use with slickline, so it goes into the mechanical firing heads as well as these electronic triggers. Now, when we look at section 7.6.2, specifically the electronic using electric initiator devices, there's a few things that RP67 requires that we comply with. They must incorporate a combination of multiple sensors. These can consist of time, temperature, pressure, or acceleration. When we get into our QTC, you'll see that we have all of these, plus both pressure and temperature are mechanical and electric. So there's a lot of redundancy and a lot of variable usage that you can get from these. The trigger must have two independent purpose-designed safety features. So if we take those different sensor arrays, at least two of them must be utilized in order to safely use this device ballistically downhole. The device must allow electric before ballistic arming, so EBBA practices, for those of you in the perforating world. That's one of our golden rules. It essentially allows us to hook up the detonator to the initiation device or the trigger before we install the detonator onto the ballistic device itself. So if you're using a perforating gun, that allows us to make the electrical connections while the detonator is still tucked away safely in its protection tube, the arming tube. And then once those electrical connections are made, then we can attach it to the gun. The last item here that the trigger must incorporate and does is you're able to do your well site checks. So the connections can't be hidden away. You need to be able to establish that there is less than 0.5 of a volt and less than 25 milliamps of stray voltage or current coming from the tool or the line or anywhere that we're hooking our detonators to. So that all needs to be complied with. As far as designs of the triggers, a couple other things that they need to comply with. This is typically done with third-party testing. There is no single point failure, so if one processor was to fail and try and go ahead and initiate the device, it's got to get through a second barrier, so the chances of that happening are very, very small. It must have an isolation barrier between the battery package and the ballistic device itself. Must have separate and independent control mechanisms, so you couldn't be running two temperatures off the same temperature control. You must have two independents. And then it must physically restrict unintentional initiation. So if it was to get crushed, if there was any mechanical problems with it, if it dropped down whole or closed instead of blind ramps, that it won't initiate the firing sequence. So all that has to be taken into consideration when the QCTs are designed. Now, as far as how these tools operate, as I mentioned, the Spartek QCT does have time, pressure, and temperature, as well as acceleration, so gravity sensors. Typically, you're going to be running the tool in three different modes. There are a multitude of combinations, but the three most common will be an elapsed time activation, a pressure pulse activation, or the accelerometer activation, where we move the tool. And those are pre-programmed and predetermined prior to running into the wellbore. So you would set up that program, design a process that you want to follow, and then program the tool appropriately. Now, when we talked about our detonating systems a couple weeks ago, we discussed group 1 through 3 as far as detonators are concerned, where the group 1 is RF sensitive, stray voltage sensitive, group 2 being the resistant detonating systems, and group 3 being the immune detonating systems. So immune to stray voltage, just immune to RF frequency. The kind of the regular packages that the QCT utilizes or has modules for are typically group 3 detonating systems. So you can see here there's a few different variations out there. We have modules for all of those. The other thing that we're able to initiate is an igniter. Slightly different than a detonator, slightly different rules, but there is an igniter module as well for setting tools and other devices that require low explosives to be initiated as opposed to perforating guns and whatnot. Okay, these modules are interchangeable at a field level, so if you were to say want to set a bridge plug and then fire a gun, you could switch out the fire module in the tool string. And as far as the detonators themselves go, that is something that the manufacturer of the detonator will have already determined, and that paperwork will be available. Same with if it's a group 2, that paperwork will be available by the manufacturer of the detonator, and then we'll work with them to comply with the requirements they need for a Group 2. When we attach the different ballistic packages to our devices, they will typically require some kind of specialized sub, and those subs are typically from the detonator supplier. So depending on how they want to put the detonator package in there, how we're connecting it to the gun, there will be some associated equipment that will be required, which may or may not be standard for other operations. So capping chambers, top subs, detonator connectors, and whatnot. So your business development managers will be happy to work with you to make sure that you have everything that's required to fulfill the usage of the tools. As far as the ballistics packages or the QCTs themselves, they're pretty much similar across the spectrum, short of what they're able to fire. Now, when we're looking at the QCT, there are 4 main components, with the top sub being typically a 15/16 sucker rod connection, as kind of a standard slickline connection. Now that can be, it's just a stub, so it can be machined to specific connections if required. Again, the slickline connection is kind of what it comes with off the shelf, but definitely it's just a stub up top, so it can be machined however. Sorry, and you see a little pressure access port that feeds down to the electronics housing. Inside the electronics housing, we will find the module for the ballistic package. In here is where we find our electric temperature, electric pressure, our clocks, and our accelerometer boards, and then the trigger itself and the voltage generator board in order to convert the battery power into a firing sequence. Then we do have the battery housing. There's a couple options on these housings, depending on what you're using it for. You can either run a 3-cell C battery or a 3-cell CC. Again, they're battery configurations, so they're able to be adjusted as accordingly. Kind of the standard off-the-shelf lithium batteries, we're looking at a temperature range of 165 C. Now the tool is capable of going higher than that, but that's where the battery limitations kind of place us. There has been extensive testing, and the tools have been qualified to 18 days at maximum pressure and still be able to supply the appropriate firing voltages and amperages. So that was third-party tested. They can last a lot longer than that depending on your battery configuration. The last item is a mechanical switch. It's a pressure temperature safety switch. In here there is a mechanical pressure and a mechanical temperature switch, both of which need to be actuated in order for the tool to fire. This is that safety barrier between the perforating gun and the battery housing and the electronics. When we put all this together, if you're using the short battery pack, we're looking at about a 1.45 meter device, or 57 inches. If you're putting on the longer battery pack, you're talking about 61 inches or just over 1.5 meters. The tool diameter is a standard logging tool size of 1 11/16 or 43 millimeter. So again, all pretty much standard stuff, nothing really out of the norm there that would cause us to need special pressure control or special adapters. As far as surface interface, again, a pretty simple package. The software, the unifier software that controls the programming and data retrieval from the QCTs are available as a download off the Spartek cloud-based database. So, and they run off a standard PC laptop with a USB connection. So if there's any laptop issues, or heaven forbid one gets lost at the airport, not that that ever happens, you could still perform the operations by just setting up a laptop, downloading the software. There's no special keys or anything that go with it. It's able to talk directly to the tool. There's a small interface box depending on the types of connections we're using, but that ties into the top of tool, which allows us to communicate directly with it. Now, as you'll see coming up, this system is not able to fire the tool. That's one of the parameters of triggers, that you cannot have a computer system actually fire it. It must meet the physical parameters of these safety lockouts. Now, as far as overcoming those safety lockouts, if you do need to or desire to test the system prior to deploying it, or for training purposes, there is a operational checkout kit that is available. It's placed nicely in a large case so that it can be easily transported and brought to location with you if you require, or to remote operations or offshore. Inside you'll find some pump, a pump with some manifolding and multiple connections so that we can apply pressure to each of the pressure sensors, both the electronic and the mechanical. There'll be a heat gun that will allow you to bring the tool up to temperature so you can meet the parameters of the safety basement settings. Again, that all comes in a kit and is easily field deployable if you need to. Now, as far as the safety feature of a QCT, when we're looking at downhole triggers, there's a parameters to make sure that they do not initiate unintentionally at surface. So what you will find inside the tools is there's going to be some safety interlocks when you're running the tool into the wellbore. You must overcome those interlocks in order to initiate the tool. So unless those interlocks are met or exceeded, the tool will not actually go into an armable mode. And there's interlocks on both the electronic and the mechanical systems, which we'll talk about as we come up. So once you're in that lower depth range, you've met the temperature parameters and met the pressure parameters, then we're able to start off the program or pre-programmed routine in order to detonate the devices. Again, this is all so that you cannot fire the tool at surface, and as well there's it's blocked from having a computer override any of these parameters. They must be physically overridden in order to test the tool as well. Now, as far as the electronic portion of it, we're looking at 2 sensor microprocessors existing in the tool. There are 2 processors for the sensor arrays are the pressure and temperature sensor, and then there is a microprocessor that is operating the accelerometer, which allows us to do gravity impact detonation. There is a 3rd microprocessor that controls the time and the memory of the device. So all the data is recorded to memory for post-operations download and review. As well as the electronic features, there are mechanical features, the pressure and temperature safety switch, and they also have predefined parameters that must be exceeded in order for you to be able to successfully detonate a gun. Unlike the electronic, where those programs can be adjusted electronically through the program, the pressure temperature safety switch are hardwired. So if the standard settings of 500 psi and 50 degrees centigrade are not within your parameters, then those will have to be physically changed out with different modules in order to change those parameters. Where as far as the electronic, that's just hooking it up to a program or to a laptop, and you can go in and reset those parameters where you desire them. Now, we do have basements on the interlocks. So when we're talking the time, there is a 5-minute minimum time in between each event that is hard-coded. So as the tool goes through its programming, there will be a minimum 5-minute delay on each step. The program itself can go up to 30 days. There is, by default, a 30-day maximum Again, this is hard-coded into the tool, so if it's nothing you can bypass with a PC, it would have to be modified specifically for needs if there's a need to exceed that. But what this interlock allows, that if there is something has gone wrong downhole and that gun eventually needs to be returned to surface, after 30 days, it goes into an all safe mode. Cannot be reinitiated. People cannot accidentally initiate it by shaking it or pulling it out of the hole or fishing it. So the tool will go into an absolute safe mode in 30 days. Now it can be programmed sooner than that, but that's the maximum you'll get out of there. As far as electronic pressure and temperature, there is a 200 PSI basement and there's a 15,000 PSI ceiling. If the tool goes below or above those pressures, then it will not be able to fire. And same for electronic temperature. There is a 5 degree and 175 centigrade or 40 to 350 degrees Fahrenheit basement and ceiling that the tool must be operating within those parameters. If you take them outside of that parameter, they will go into a safe mode. And the reason it doesn't go colder than that is typically in the wellbore, we don't see temperatures colder than 5 degrees. On surface you may, so if you're trying to do surface testing, it's going to be required to move it into a warmer environment than our typical Canadian brisky afternoons that we're about to see here in a few weeks. Again, the default on the hard-coded switch, as I mentioned, they come with a 500 PSI and 50 degrees centigrade ceiling, or sorry, basements. If you need parameters outside of that, they will need an actual an upgrade or downgrade in the at a Spartek facility. It's not something that can be done in the field. If at any time the tool moves out of these parameters, it goes into a safe mode and will not initiate the firing sequence. So in the real world, how does that actually work? So we're going to take a look at kind of the 3 most common activation modes. The first one being elapsed time. It's kind of the simplest, most basic. We're just going to set a clock and run it in the hole and initiate our device. So first thing we want to do is actually run into the hole. Now when we do this, we're needing to exceed the parameters of our pressure temperature mechanical safety sub. So that's at 500 PSI and 50 degrees centigrade. That will allow the firing sequence to transmit to the ballistic device, okay, before we even start our time sequence. So once we've met those parameters, we can move forward. While we're doing that, we'll be in our depth control window, so you do need to give yourself enough time to check your depth control. We had a couple questions on the last couple of seminars about how do you do that with slickline or coil. There's a multitude of ways. If you're tubing conveyed, you'll probably log it in with logging tools, so you're going to need to account for that time. If it's slickline or coil, you might be using a mechanical collocator, some depth stops, nipples, tagging bottom, or you may need to make a dummy run with a gamma CCL in memory mode and check your depths that way. So there's a multitude of ways to make sure we're in the appropriate depth, and they can be set by either depth or by pressure or by temperature. Now once we've passed that safety time where we've pre-programmed the amount of time we need to get everything on depth and we're happy where we are, and we're within those firing parameters, both of our mechanical and electric tool presets, we will go ahead and start the initialization. So we'll, once we've entered those parameters, our time will have started and it'll be on a countdown mode. Once we're in that countdown mode, it's going to wait a certain period, minimum of 5 minutes. This allows you to move outside of the interlock parameter. So if all of a sudden there was a change in thought process or somebody's not ready for the gun to be fired or the well to come online, you can pull the system out of that parameter at any time, and that will reset it. And you're allowed up to 15 resets before the tool goes into an all safe mode and cannot be reinitiated, but it's got several reinitiation sequences built into it. So at any time, if you pull outside of those temperature or pressure windows, you will reset the clock for your interlock time. And once that interlock time has been successfully sat through, then the trigger will go into the trigger delay mode. It takes about 5 minutes, and then it sends the appropriate firing sequence for the ballistic package that you have on board and get a successful fire. So like I said, that's kind of the simplest format. We're not using any real parameters as far as programming temperature or anything short of what our basement windows are. For pressure activated, or sorry, for tubing conveyed pressure activated, as opposed to an absolute firing head, we're able to use a pulse mode. So you take your hydrostatic pressure, and instead of having to exceed the safety parameters of a standard TCP, we're able to use activation pulses, just a few hundred PSI, as opposed to potentially thousands. Again, same as the first one, we will deploy to depth, make sure that we are inside of our mechanical parameters for both pressure and pressure and temperature. They will also have a time delay as sequence, so it gives us enough time to put everything on depth once we're in that window, and then make sure everything's in the right position. Now we can go ahead, so we're happy everybody's where they're supposed to be. To execute the firing sequence on this one, we're going to use a combination of time and pressure pulses. So we will have our baseline temperature, so we'll set the tool in a steady state. That will be predetermined, close within an envelope of what the bottom hole pressure is expected to be. If you've measured it pre-run, even better, then we know exactly where it's going to be. And we set those envelopes. Once we're in that envelope, we have a baseline time that we want to overcome, so typically 10 minutes or so. And then we're going to set up a minimum of 5-minute window where we want to give it a pressure pulse. So we will increase the pressure above or below the, so we can bleed off a little pressure, we can increase a little pressure to give it that pressure pulse above the baseline window or envelope. Staying within our safety interlock, so we want to do all of this in the safety threshold. After we give it the first pulse, it's going to reset a clock inside and give us 5 minutes to set at a steady state again. And then we're going to hit it with a second pulse. Now you can have multiple pulses. This one just is 2, but you could have several, or you could have 1. Once we initiate our second pulse, you can either bleed it back down or you can keep the pulse on it. The firing sequence is actually going to begin once it sees that pressure above its steady state or baseline envelope, and that will initiate the triggering, which again, minimum of 5 minutes, and we'll send the firing sequence to the detonator. And as long as we have stayed there and not moved anything, the tool will go into a fire state and we'll fire our ballistics package. The last one we'll kind of go through here is the slickline operations of the QCTs, where we're using line shake. So we're not playing with any of the pressure controls or anything, just strictly a time and pressure, or sorry, time accelerometer. So again, we run the QCT to depth. We exceed the parameters of the mechanical safety switches. We exceed the preset time, so minimum time for the trigger to initiate. Again, that's all predetermined with your program and pre-programmed with the laptop. Once you're happy that depth control is on, then we're going to execute our firing sequence. Now on this firing sequence, we've set this one up for a 2-burst firing sequence, so it'll be 2 line shakes. Actually, it's going to be 2 bursts of line shakes. We have a couple of line shakes per. So we're going to have a standstill, very similar to our baseline that we saw in the pressure. This time it's a movement standstill. So we're going to leave the tool at a steady state for a set amount of time. Then we're going to pre-program in accelerometer bursts. So you could set in 2, 4, however many you desire as a safety parameter. Within that burst, that's the minimum it wants to see. So if you set it up for 2, but you want to give it 4 just to make sure that you saw that gravitational movement, again, then that's pre-programmed. You can give it a small or large, something that you'll want to test to make sure that you're achieving that. So you give it the 2 spikes. Once that second spike has been initiated, then you need to go back into a standstill mode again to reset its clock. It's going to count down for another few minutes. And then we give it a second burst. Again, this can either be done with jars or spangs or tool movement, however you want to get that accelerometer to work. Once it has seen the second spike, it then goes into the countdown for the trigger delay. And we've got a 5-minute, and then it's going to send the signal to the ballistics package, and we get a successful initiation. So again, lots of versatility in these things. They can be used in multiple ways. When we're looking at TCP configurations for tubing conveyed firing heads, kind of the standard would be a single firing system where you just have that ballistics package, the QCT right on top of the firing head, and initiate the gun either using pressure or time or a combination. One of the other options is because they're 43 millimeter, they're small enough that you could tuck them in beside an absolute mechanical pressure activated firing head and be able to have that as a backup redundant system. Or you could actually run 2 QCT packages, where one being the redundant, so they both are set to reduce any chance of failure. You'll have redundant systems. So again, they can you could be doing the same process to both tools at the same time. They'll be reading the pressure pulses and time independently. As I mentioned, the third-party testing, there's been quite a bit of it done. This tool's been around for a while. It's gone through a few generational changes. It's gone through all the gamma ray interference on the electronics, just to make sure that no conditions downhole initiate anything. Vibrational testing. We talked about the 18-day. That's actually at 165 degrees maximum temperature. So that was done and witnessed. One of the other ones that ones that was tested is heavy mud systems. So there is some screens and filters that we can apply to the device in order to operate in a heavy mud system, and then all the compatibility with the detonator packages that's available. So just a quick summary. As we mentioned, the initiation systems can go all the way up to a group 3 compliant, so immune initiation systems. The QCT falls into full compliance for triggers as laid out in RP67 edition 3. I hit briefly on the delay multiple restart failsafe operation, where if you at any time pull the tools out of their set parameters, you will reset them. So if you go back into those parameters, the tool will start from scratch, and the clocks will all start over and be looking for the pulses, be it pressure or accelerometer. Again, you're able to do that up to 15 times before it goes into an all safe mode, where you're no longer able to restart it, and it needs to be removed from the wellbore, brought to surface. It can be run under balanced. And the other thing that's has been tested is the vibration and shock testing for both standard and inverted operations. So if you do wish to run this on the bottom of a gun assembly, it can be used to initiate from top down or bottom up. It doesn't really matter to the tool which way it's facing. All right, so that brings us to the end of the QCTs. So we're going to move on to the FAST gauge. So again, not really a ballistics package, but it is primarily used to record downhole ballistic events. So this gauge was designed to capture primarily TCP or perforating operations. And there you go. Okay, so it is a sapphire gauge with a high resolution pressure sensor. It operates up to a temperature of 170 degrees in standard configuration, so can be deployed on E-line or tubing conveyed. It's designed for use in perforating jobs. The tool is actually can be run either in a hanger, which we'll show, or can be attached directly to the guns. It has a burst sample rate, so when it's acquiring the samples of the gun, it's 39,000 samples per second, so an extremely fast sample rate to capture the ballistic event. And it can be triggered in multiple ways using differential pressures or absolute pressures. A very large memory capacity, 4 million points of data can be stored. And as with all of our gauges, it is USB ported so that it communicates with any PC-based system using the SparWorks gauge programming and data retrieval software. And that software is also downloadable off the cloud, so if anything happens to your laptop, you're able to reload the software remotely. Now, as I mentioned, there's depending on how you're running it, if you're running it on wireline or tubing conveyed, they are 1-inch gauges, so they tuck nicely into several places. You can either run them in a gauge hanger, like you see in the picture there, or on the bottom hole assembly diagram. You can see they're on the bottom. If you're wishing to retrieve them, they can be placed in a gauge hanger above the gun, so that they're locked down during the event, but then they can be retrieved to surface. They are not remote data transmitting, so they do have to be retrieved to surface to download the information. Now there's 3 modes that the tool operates in. The standard mode, it acts just like any other gauge. So you can have set it up for a sample rate of 1 sample per second or slower, 1 per minute, depending how you want. This completely programmable. So if you want to capture other information as you're running in the hole, if you're doing any gradients or any information like that, the tool will capture all of that. It does have temperature as well as pressure. Once we're getting to where we want to capture the ballistic event, we're going to trigger the tool to go into its moderate mode. What this does is it initializes a capture rate of 10,000 times per second, and then storing that information as per your specified rate. So you wouldn't typically store it at 10,000 times per sample. You would take a portion of those samples and record it to memory. But what it's doing while it's at that high sample rate is it's buffering a burst mode. So the burst mode is kind of running, but it's not being recorded. Once the ballistic event has happened, and the violent reaction that we see with those, the burst mode activates and captures, goes into a sample rate mode of 39,000 samples per second for about 230 milliseconds. This gives you a grand total of just over 9,000 samples that's stored over the ballistic event initiation. While it's in that mode, it's going to do a couple of things. It's going to stay in that mode for 5 seconds, because once it downloads those 9,000 samples, it needs to store them to memory, which takes a little bit of time. But the other thing it's doing is, as I said, there's a buffer mode in the moderate mode, and it's going to capture 500 samples pre-detonation. So you're going to get a small data set prior to the event happening. We've got a couple sets here that'll kind of show you how this works. So the upper image there, this is we've gone from a normal to a moderate trigger rate. So we've had a pressure pulse that we initiate when we trigger the tool to go into moderate mode. And then once that moderate mode records the ballistic event or sees it, it has that buffer of 500 samples. And the clock kind of backs up a little bit and then starts that 39,000 samples per second for the 230 milliseconds over top of the perforating event, and captures a very high rate of pressure that we see occurring there. Now, to trigger that moderate mode, as we mentioned, there's a few different ways you can set the tool up to trigger those. There's either a delta increase or decrease in pressure, so a differential pressure change. So we can spike it with a pressure pulse, or we can actually set it to when it meets a certain pressure, an absolute high or an absolute low for bleeding down the well or increasing the well while the tool's in the well bore. And this is all programmable from the Spartek system. You go in and set those pre-programs up, and that can be done on surface, on location, or it can be pre-done at the base facility. And we've got a couple examples of what you can expect to see with these tools. So this first one is a perforating tubing conveyed job. Now, they didn't actually use the burst control on this one. The company opted, and that shows the versatility of this tool. They opted to leave it in a moderate mode with a very high sample rate, but a consistent high sample rate throughout the job. So the tool was run into the well, so you'll see that increase once we get to our desired depths. So this well is about 5,000 meters, perforation depth, so about 16,000 feet. It did have an oil-based mud in there, so 1.45 specific gravity, or just over 12 pounds per gallon. Bottom hole temperature is 73 degrees centigrade, or 164 Fahrenheit. And then our bottom hole pressure, our baseline pressure, was expected to be 4,500 psi, or 31 MPa. Again, the customer set a high sample rate without using the burst module on this one. So once the gun detonated, that was captured. There was the moderate was fast enough to capture most of the event. And then what they were primarily interested in as well was their secondary operations, so post-perforating cleanup and stimulation jobs. So the gauge is able to capture that at a very quick rate as well. And as you can see, you get both temperature and pressures come in. And then we can see the trip out of the hole. So this entire job took about 18 hours as it was being tripped in and out on pipe. And once the tools were brought back, they were serviced and returned to operation. There was no damage to the gauges. Again, these ones were attached directly to the gun itself. They weren't in a housing or anything. They screw right into the gun. Now, the second field operation that we've have the opportunity to share with you. This one's a perforating depth of just over 2,700 meters. The wellbore fluids were undisclosed. There was a mixture of multiple fluids in there. The expected bottom hole temperature was 92 degrees centigrade, or 197 Fahrenheit. And our expected bottom hole pressures were about 6,000 psi. Again, this one was tubing conveyed with the gauges attached directly to the perforating gun. The trigger for normal mode, to go from normal to normal to moderate, at 7,200 psi, and the absolute lower to turn off the moderate was set to 5947. So in and out of the hole allowed us to use all three recording rates. So we see the normal rate here switch because it's very fast. We've got this zoomed in quite a ways. It looks like a bit of a slope, but it was pretty linear. Once it saw that trigger at 78, so between 6,000 and 7,800 is when it triggered to moderate mode. Saw the pressure pulse to fire the gun. And once that pulse initiated, we went into the moderate mode where it was capturing 100 samples per second. And then we see our firing pressure, which They pressured up, dropped off, and then we saw our gun detonation. Now, when we zoom in on that, this is where you can see that 500 samples in the burst that's captured pre-event. And then there's 230 milliseconds of 39,000 samples per second captured, which is quite a bit of time in the perforating events lifespan. So that goes over very fast. And then it goes back to a moderate rate. This whole capture process takes about 5 seconds. So a little bit of time in there to capture and record everything. And then exits burst mode. And again, successful tools were run in the hole, pulled out and serviced and returned to operations. So just a quick review of parameters of the tool, or these tools, just go through them. They do have an operating temperature at 170 degrees centigrade, max pressure at 2000 psi, housing of Inconel, so they are sour service, corrosive environment rated, and 1 inch diameter with a makeup length of 13.2 inches. So typically you'll run 2 of these together. Some companies will run a standard gauge and the fast gauge. They can either be run side by side in a carrier, or they can be tandemed up together end to end. So depending on which configuration works best for your operations. And yeah, so maximum sample rate at 39,000 per second, and it does have a memory capacity of 4 million data points. So most of these jobs, especially on tubing conveyed, plenty of time to capture those. And again, you can set your clocks to turn the tool on and off if you're worried about exceeding that, if you're in a modified moderate to burst rate, or capturing something unique. All right, well, that brings us to the end of our presentation. Try and keep it short and sweet. We appreciate that you guys give us a little bit of your time. Thank you for that. So we'll value that by keeping this efficient. If you have any follow-up questions, again, we'll leave the chat and we'll turn everybody's microphones on here so we can discuss. But if you have specific questions, by all means, please reach out to your local business development managers. We are a global country, so short of Antarctica, you'll find us just about everywhere. If you require any additional information on any of our product lines, we'd be happy to hook you up with catalogs and any specific operating information you may require, and happy to help you out or talk more about any of the product lines.